Welcome once again. I'm Charlie Greenberg, your host and moderator for Digital Business Demos. This is the series where we provide live business demos that focus on different digital transformation and platform strategies, and in particular, demonstrate different components and products within Software AG's digital business platform. Today, it's all about Zementis, an exciting new solution for artificial intelligence and one used to enable machine learning in predictive analysis for fraud detection. In just a moment, we'll be hearing from Mark Rapkin, Director of Business Development, AI Strategy and Innovation, and Eddie Soong, Global Senior Pre-Sales Engineer, who will be executing today's demo. But first, I'd like to point out that Zementis is part of Software AG's digital business platform, and that Software AG is a customer-centric leader in many innovative and digital technology categories. We have more than 4,300 employees, $1 billion in annual revenue, and we can cite over 70% of the Global 1000 as customers. And as we proceed through this particular deck, those customers, as you'll see, include well over 2 million developers at leading organizations who have adopted web-methods products to innovate solutions cross-industry, cross-private, and public sectors, and who rely on Software AG to complete their journeys as digital enterprises by using the end-to-end capabilities of the digital business platform. Also, please keep in mind that following Mark and Eddie's presentation, we will provide a Q&A session. So as usual, please use the WebEx Q&A box at the bottom right-hand side of your screen for any questions and comments. And with that, it's my pleasure to introduce Mark Rapkin.
Thank you, Charles. And I guess I was a little bit of a slide behind in terms of the customer slides, so I apologize for that. And Charlie mentioned that we do have thousands of customers. So the agenda for today is the introduction and overview of Software AG that Charlie gave. I will give an overview of Software AG, and then Eddie will build a model using our show how to deploy that model using the Zementis predictive analytics, utilize that model within a complex IT environment, and then we'll get into a solid demo as well and do the Q&A that Charlie mentioned. So that's what we're covering today. So the first thing I want to comment on is that the future of AI is already here. If you look at the industries and companies investing, these investments are being made today. But I also want to clarify what we're talking about when we talk about AI, the term, or when you hear that used in conversation today. Because what people are not meaning when they say this is the singularity, i.e. the computer that you cannot differentiate from a human being. What they're talking about is things like data mining, predictive analytics, machine learning, deep learning, data science. And where the term has come from is that for the last 10 years or so, we've been using the term big data and analytics. And all marketing terms have a half-life, and the term big data and analytics to a large degree ran its course. And now, because of more advanced techniques being used, people are referring to these same big data and analytics techniques along with the new techniques as artificial intelligence, or AI. So it's good to know that when you're in conversations with technology executives, with business executives, when you're reading the press, that is generally what they're referring to. For anyone involved in this market, you know it's growing quickly, but it's nice to see some statistics. Here we are in 2017 with probably less than $1 billion a year being invested in the sector, but that's going to over $11 billion a year by 2024. And we see this even in rather elite conferences. So we're involved with a conference called KDD, which is an annual conference, one of the elite data science conferences where folks will publish very academic-oriented papers. And last year when it met in San Francisco, there were over 3,000 attendees. And I think from looking at who registered, a lot of you probably go to Strata, and we've seen the huge growth in the interest in data science as well, and the data science track at Strata over the years. So it's reflected. Now, why is there this interest? Why is this investment, and why is this such a hot topic? And it comes down to the economic value that becomes available when you can take advantage of the data that devices and people provide. And let me give you two examples. And I can't see those of you who are attending, so I don't know what the age range is, but perhaps a few of you used a browser before Netscape and Explorer were popular in the late 90s. Maybe you used AOL. Think about how much economic value has been created when the data that we can access through a browser became more available and usable to consumers as well as to companies, right? We know that there are entire companies like Amazon that have grown up around this, just to name one, right? And entire industries, of course. So actually trillions of dollars created by enabling that data and then companies taking advantage of that data using predictive analytics, machine learning, and AI. Now that's an older example, and I realize again, some of you might not have used the internet at that point in time, but maybe many of you had a mobile phone before they became smart, right? So, you know, maybe you had a Motorola Razr or something else, right? And then the iPhone was introduced in 2007. Sure, there was the Palm Pilot before that and things like that. But think about over the last 10 years, how much economic value has been created by the wide availability of data in a mobile fashion, in a broadband fashion. And again, you're looking at trillions of dollars that have been created through the use of this data and predictive analytics and machine learning and AI, right? And a lot of value delivered to consumers, whether that was in, you know, the private sector or the public sector. And I'm having a little trouble, there we go, advancing the slide. But in order to do this, Forrester Research has a great concept called the perishable insight, in that, you know, if you're looking at a shopper's response, whether they're on their website making a shopping decision, you might have at most a few seconds to respond before that data doesn't become valuable. Today we're talking about fraud. You know, when you're talking about e-commerce fraud, you're talking about credit card fraud, you have a few milliseconds to respond. In an industrial IoT environment, you know, you might have a little bit more time. But there are two types of responses. There's the type of response I've just been talking to, but there's also the ability to deploy the analytics quickly, because in the world we live in, right, these models have to be updated frequently to maintain their competitive advantage, to keep delivering smart, actionable decisions that deliver economic value. And so I want to grab your attention, if I can, before I go to the next slide. I know this is a webinar. Many of us multitask when we are listening or attending webinars. But I want you to look at this next slide and listen to what I have to say for the next minute or two, because it may be the most impactful slide you see in a while. Oops. Let me advance to it. There it is. Here are the companies some of the companies who have already realized the value of AI, right? Amazon and Apple and Facebook and Google, as well as Airbnb and Uber. Now you'll notice that Airbnb and Uber don't quite have the same valuation as these more mature companies. But investors are still pounding to get into them because they think that in 5 or 10 years they'll have similar valuations. Now, you may be working at a company that is never going to be an Amazon or Google or Facebook or an Apple. I get that, and I want to fully respect that. And I know there's a lot of consulting folks on the call as well, and your clients may be in that same situation. But what if you can be a leader? What if you can be part of a team or influential in your company, realizing anywhere from 1 to 10% of this kind of increase in value due to the implementation of AI. What would that mean for your company? What would it mean for the brand? What would it mean for your personal career? And by that, I mean your economic circumstance. Because there's an opportunity here, right? And, you know, Software AG regularly has companies that invest tens of millions of dollars with us on initiatives that are based around leveraging this data and getting more value from it. And if they're investing that kind of money, what kind of return do you think they're expecting? How much money do they have to drop to the bottom line? How much money do they have to see in revenue and profit? So this is really real, and the time is now, and it's really one of these unique opportunities to really take advantage of something that's really big and exciting and fun to work on. Whoops, I went one slide too far. So what I want to talk about is how you do this. And so what data scientists do is they design solutions to business problems. They develop the mathematical techniques that live within applications that solve these problems. And to do that, they have to train them during the development process and test them, and then they need to deploy them. And we're going to talk about deploying models using an open industry standard called the Predictive Model Markup Language. And with Zementis Predictive Analytics, or another version of it that we offer called Palmer Predictive Analytics, these integrate directly into Software AG's digital business platform. Now, not only do we integrate into Software AG's digital business platform, but we integrate into pretty much any IT environment you would like. So the idea behind this slide is that if you look at the left-hand column, you have a sample representative listing of tools like SPSS and SAS, as well as R and Python, and a sample representative listing of machine learning techniques, as well as deep learning. All of these can be exported to the Predictive Model Markup Language, or PMML. And what Zementis Predictive Analytics does is it consumes and executes and optimizes and scales PMML for any IT environment. So whether that's a Software AG environment, from web methods to Apama to mainframe stuff on Autobot and Natural or Terracotta in memory. Or you can put it up on the cloud, whether that's Amazon Web Services or Microsoft Azure, or you can put it in a distributed environment on top of a Java application server, or in a Hadoop Spark or Storm environment, or run it on an IBM mainframe. So we're providing this write once, deploy immediately, anywhere capability for AI, machine learning, and predictive analytics. Now, why do we need that solution? So let's take a look at how predictive analytics and these sorts of things are normally developed and deployed. Again, the data science team is going to use tools, often things like IBM SPSS or SAS, or maybe something more contemporary like KNIME, or languages such as R, Python. But they're doing this in a development sandbox environment. And so when they've gone through that process of development and training and testing, and it comes time to deploy, they need to contact IT. When they contact IT, IT says, great, give me a write-up of the business problem you were trying to solve, how you were trying to solve it, and then IT reviews that, gets back together with the data science team, and there's some questions, and they go back and forth a few times. And then eventually the IT folks get around to beginning to code this model so that it can be deployed in production. Keep in mind, this is for one model. And meanwhile, the IT folks are trained differently than the data scientists, so this takes a little while, right, to get done, and there has to be some back and forth and some iterative development cycles. And meanwhile, occasionally people get pulled onto other priorities, or there's a reorg, or somebody gets sick, or people go on vacation. Once in a while, someone leaves the company. In other words, for each model deployment, there's all the friction and stress of any IT project. And what we see in the large enterprises is for a large new model, it will take 6 or 9 or 12 months to get deployed. Now that's for, it'll be less for a smaller model, less for an revision to an existing model. And companies, this was okay 4 or 5 or 10 years ago. A lot of companies had a half dozen to a dozen models. So it was a business process. It wasn't ideal, but it more or less worked. In today's world, chances are if you're listening to this webinar, one of the reasons you're listening is because Software AG is a leader in enabling companies to go through a digital business transformation. Another way of saying a company is becoming more digital is to say they're becoming more data-driven. This idea of deploying each model on a manual basis, when you're moving to dozens or hundreds or possibly thousands of models, and it's a core part of your competitiveness, does not work. It becomes a high-priority business process that is broken and needs to be fixed. And for those of you that are consultants on the line that are doing data science, this capability can allow you to get those projects done much more quickly, deliver more to your clients at less cost, which is always a big win for the consulting companies. So why has this changed beyond simply the fact that the world has become more digital and companies are competing in this digital environment? Well, there is the low-cost availability of high-performance computing, and that has enabled the data scientists to use much more complex models. So the models that they're using when they get into random forest models or neural networks are much more complicated to custom code. The models have to be updated more frequently because the environment's more dynamic, and there's a lot more data diversity. It's not all just structured data anymore, right? And there's a lot of unstructured data, be that social media or multimedia data. And the IT environment over the last 10 years has changed a lot, right? We've had Hadoop and then Storm and then Spark and there's Ray and there's Apex and there's other stuff, right? It's all coming. So the whole environment has become much more complex over the last several years. So when Software AG sees complexity in an IT environment, what we want to do for our consulting partners, what we want to do for our clients is we want to rationalize it. We want to simplify it. We want to make you more effective and efficient, have less cost and more money, more time, more resources for innovation so that you can compete. So on the data science side of things, what we don't want to do is change what the data scientists do on a day-to-day basis. That's very hard to do. So we want them to be able to use their tools or languages of choice. And when they have developed their model, all they need to do, and we can support them in this, is transform that model into this mature open industry standard called PMML, or the Predictive Model Markup Language. What the Zementis software does is it consumes, executes, optimizes, and scales PMML, again, for any IT environment. So now you've got immediate deployment of these models. No custom coding, no headaches, no delays. The huge economic win, it's a way that companies can have the capabilities in-house to compete with the digital disruptors that they're facing. What I would also say is that we're really talking today about risk management analytics that's on the right. The demo is all about real-time fraud, e-commerce fraud, and that sort of thing. But I want to be very clear that the Zementis products really only care about math and data. So they can be applied to marketing analytics. They can be applied in IoT environments. What we're doing with that PMML is converting it into a very lightweight Java runtime so we can run out on the edge of IoT networks and have analytics on the edge or in the fog or in the cloud or centralized server, wherever you want them to be. And I believe that now I'm going to turn this over to Eddie for his portion in the demo.
Thanks, Mark. Hello, everybody. My name is Eddie Sung, Software AG, Zementis, and AI specialist. Let me share my screen, and I'll get on my way here with you guys. All right. Today's digital business webinar topic is about embedding machine learning to combat fraud. I wanted to start off by showing you an example of how machine learning is used in fraud detection, and then explain how it was put together, i.e. how we embed machine learning into business processes. Let's begin with an illustration of how the high-level architecture block diagram of the demo that I'm going to show you is conceptually put together. On the screen, you see that I'm using the integration servers by Software AG Web Method. This is the mechanism or the platform that I'm using to make the fraud detection machine learning application as a service. And the scoring, or it's also called, when we say scoring, it really means prediction. The prediction of data, in this case, e-commerce transaction data, is done at the Software AG Zementis server that you see on the left here. And what I'm going to demonstrate today covers just these two blocks, and I will go deeper into each one of those after the high-level demonstration. At the same time, I want to point you to two other areas where we could also insert or embed the machine learning capability, and that is the API management, BPMS, here as well. Not on the diagram here is also a PAMA, our real-time complex event processing platform. We can also embed it there. So essentially what I'm saying is that we can embed machine learning in any platform, literally any platform that Software AG carries. Now, let's go back to what this actually looks like in a running demo. On the screen here, you see a dashboard which is provided and rendered by a Software AG Mesh Zone product. And what it's doing is it's taking the feed from the Software AG Web Method integration server, where it channels the e-commerce transaction record and then passing it on to Zementis for prediction and providing the results to Mesh Zone for visualization in this fashion. The ones that on the left quadrant here, you see a table, and I'll start the process as soon as I'm finished describing it. Actually, let me do this at the same time. There is a service I was telling you earlier, which is the fraud detection service that I made into a service, and that is supported or implemented inside of Web Method integration server. It is a job that I will now start, and now it's started. And so what that job does, it intercepts, or it takes in the record, and then it passes it into Zementis server where a model or machine learning is running, and then scoring each of the record that comes through and illustrating it out here, or visualizing it here. And right now we only saw one transaction that is fraudulent, or that potentially could be fraudulent. That's why we flag it as suspect. And everything else is fine so far. At the same time, we also provide other dynamic data for visualization in terms of where the fraud is, how many fraudulent cases there are so far. In general, you shouldn't see a lot of this fraud, but if it does happen, it'll be sprinkled across a series of transactions over time, and now and then you'll see one pop up. So far so good. We only saw one so far, but eventually there will be a few that will come up. But in any case, so while we're letting it run, let me explain how some of this thing is put together. You saw the mesh zone here, and that's taking the data feed. But where's the data feed coming from? Well, it is a service, as I mentioned, but how is the service implemented? In this case, as I mentioned, I'm using the Software AG Web Method Integration Server. There is a flow service that I've created. This, by the way, is the Software AG Designer, and this is and I'm in what we call the service development page or perspective, and this is what I use to build my my flow service, which then eventually becomes the fraud detection service that will be scheduled. In here, there is a bunch of different steps that I've created, or what they call flow. And the ones that is important here is the score fraud. But the steps prior to that is just a simulation of the e-commerce fraud data coming through. Since I'm not connected to an actual point of sale system or any other system that provides real-time e-commerce transaction, I have the data batch of e-commerce transaction from before in the CSV file, so I just simulate it by reading it into memory and randomize it and randomly picked the record that I sent for scoring. But the scoring actually is implemented here under score fraud. So if I look at score fraud, you can see that it's taking the randomized record that I picked, and then it sets it up, and then it's going to call the e-commerce fraud models in here, which has the e-commerce fraud machine learning application. And then I'm going to send it off to this method called getApply. Now, getApply, if we go deeper into it, is a flow that is actually provided by a workflow package that we can make available to everyone. Later on, there's going to be in the next release, there's going to be what they call a web method package, WM package, which is a read-only package. It's kind of a library that you can use to call and send this thing to Zementis without having to implement the actual implementation of getApply. But in this case, we have a flow, so we actually set it up here to set up the encoding, and eventually we're going to call the HTTP client. So you guessed it, we're using REST API, and we're setting up the methods here. So we do a set a get, do a stream, we set up the header, and the data is already set up. We have the authentication already set up, and then it fires off, and then it gets the result back. And the result is then passed to mesh zone, which then displays it here. So we saw that there is a bunch of different, several fraud already detected. Before we only had one in Virginia, and now we have a few other ones showing up here. So we have detected a few here. So that's how it all works. Now, so let me go back to the slides, and then I'll talk a little bit more about the details of the implementation in the other aspects of the demo. So in the demo, you saw the e-commerce business process taking advantage of machine learning to reduce fraud. But what is involved in introducing machine learning, i.e., how do we embed this machine learning into this process? And if adding machine learning to any business process has been an arduous undertaking in the past, and the reason is what you have heard earlier, which is, in summary, are long recoding exercises which are error-prone and resource-heavy. This is no longer the case when you use software agents and Zementis, thanks to what Mark had talked about, which is the PMML standard, the Predictive Model Markup Language. But first, a quick explanation of what machine learning is for those who are not familiar. When I first started working on this many years ago, when people talk about machine learning, I have no clue what it is. They talk about models, I have no clue what it is, but then you try to make sense of what they're trying to tell you and how they apply it. And it didn't really help if I didn't know what it is. So I thought, from my experience, that it's probably best to explain to you right now before I get any further. So after all, we can't possibly understand how we apply something if we don't know what that something is. Machine learning is the application of statistical mathematical methods to identify patterns in data so as to be able to make prediction from it. This machine learning capability is made available as a function which is encapsulated in what we call a model. You would see a data mining tool. You would actually use data mining tools and languages like R, Python, IBM, SPSS, SAS, and Mark also mentioned KNIME. There's a whole bunch of other ones there to build such a model. Here is an example in the data mining language of R, which is one of my favorite language and tools that I use. Python is the other one that I'm starting to get more involved in to further illustrate the concept. As you can see, this on the screen here is an R script. It's a text file. This is what you write to build a model that is consist of R statements, R language. So I'm using R language to build this model, and it's written inside an R script, which is a text file. The model itself is actually one line that you see here. My model is a variable in R, and it's assigned a machine learning function, and inside the machine learning function, I apply the formula. The formula is taking a set of variables in your use case, and then what the prediction is based on those variables, and then the data that I use to train, so this thing over here. So in the example that I'm going to show later in the actual building of a model is I'm using a random forest model here. Random forest machine learning function. And there are a whole bunch of different types of machine learning functions. And by the way, that machine learning function is commonly called an algorithm. So when somebody talks to you about machine learning algorithm, that's what they're talking about. Before we can apply machine learning technique to business problems, we have to build and train this machine learning method and encapsulate that inside a model, and that's what we're doing here. My model is the encapsulation of this trained machine learning functionality. And it's we build a model by running the R script. So we run this thing here, the entire thing, and upon successful execution of the R script, this whole thing, the model will be generated. It is this model, i.e. my model, that is deployed and used to make prediction on data in production. In the case of a demo, it has to be able to detect anomaly, which has a high probability of being a fraudulent transaction. Now that you know, hopefully, now that you know that a model, what a model and machine learning is, it is also worthwhile to note that like software development, model deployment takes on a life cycle as seen in the bottom section of this slide. Building model is an art, really, and also a science. It's just not just technology. There's a certain skill to it. You need to be proficient, obviously, in using the data mining tool to build a model, know what machine learning algorithm to use, because there's a whole raft of them, as I mentioned earlier. Ability to discern pattern in data, because one of the things that you have to do in building a model is to understand your data. And then understanding the process in developing, evaluating, and operationalizing the model. Model development is done by, obviously, the data scientists or a data science team. Now, I understand that some organizations are going into this in the very early stage, and they don't have this kind of resource. And Software AG can help you in that area if that's the situation. But the data scientist goes through a typical process of importing, exploring, and transforming data before the model is created. But it also have to evaluate it and then communicate to the team who will deploy it into production. Typically, that would be the IT team. Finally, once a well-fitted model is produced, it is time to deploy it into production. This is where Software AG is a major accelerator, since it can deploy models built by any model data mining tools that support PMML standards. And it can be done within days versus months. This is made possible, obviously, by converting the model to PMML and deploying it on an Software AG Zementis. So let me demonstrate that quickly. So here it is. I have RStudio, that is an R data mining tools, very common and very popular R development tools. And obviously, I use this to build my R code. And what I want to do here is to demonstrate to you how I can quickly build an R model, which is this guy over here. But more importantly, how do I convert this to PMML? Because after all, we say that it's because we're able to convert to PMML, that's why it is more efficient to deploy and much faster. So let me just run through this. As you can see, there is no PMML in this directory here. This is the directory I'm working off. And this is the 3dtest.r is the R script, as I talked to you about. I'm going to run it. This is the execution of the R script. And it uses a number of libraries, just like in any programming language. The library PMML is the library that has the function to export, to convert the models to PMML. And the library random forest is the library that has the random forest machine learning algorithm. This is what I'm using to build my model. I'm building a random forest model right there in that one line that I'm just executing. And not only am I building that model, the random forest model, I'm also training it using this test data, this training data. Now, let's not worry about testing or whatever it is. The point of this demonstration is to show you how easy it is to convert that model I just created into PMML. And that one line that I'm going to execute now is that line that converts the model to PMML. And you can see that, you know, compared to recoding this random forest model, which takes months, within seconds, I have it converted to PMML. Now, the only thing left now is to export it into a file. And that one line, the last line, is what's going to do that. And you can see that PMML is here. What does it look like? Well, it's just a text file. It's an XML. It defines data that it uses. It defines the features that is used within the model. And then the question has always been, what happened to the data? Do I need to send the data? The answer is no, because when you train the data, it has computed the variables or the coefficients of the formula that represents the model. And that is the most efficient, in the simplest term, formula that the machine learning process was able to create. But technically, it's called minimizing the cost function. Anyway, so what do we do with this PMML? Well, we have to deploy it. How do we deploy it? We will have to, I'm going to show you one way that we can deploy this. I'm going to log into Zementis server. And you can see I'm brought into this web portal that has a bunch of machine learning models already deployed. I get all kinds of different ones, but let's go and deploy the ones that I just created. So this is the model that I just created. You can look at the timestamp. You see that that's indeed the ones that I just created. And there we go. We've got this 3D test. That is a simple, that's how simple it is to deploy. And I can do the deployment using REST API as well. So what do we do with this model once I deployed it? Well, if you look at this e-commerce fraud, that is exactly the model I'm using in the demo that I just showed you. So let's exercise that from here to use the e-commerce fraud demo. I'm going to pass in a batch of e-commerce transaction, and it scores it. So this is the score of the e-commerce transaction. Anything that has, you can set it up that anything that's more than, say, 0.8 is considered fraudulent, for example. So you can see all the features that I use in the model. I can expose it over here, and you can see that it's this is what I use, and the computed value is the score. So you saw the actual demonstration. You saw how the various components are used, and you saw how the machine learning model is embedded. Hopefully, you get an idea on how simple it is, that you're convinced that it is very simple to embed machine learning in a business process. I'll be happy to answer more questions later on. At this point, I will pass the floor back to Charlie and have him conclude the webinar. Charlie?
Thank you, Eddie, and thank you very much, Mark, as well. And before we move to the Q&A, we want to invite you to the currently available Software AG Innovation Tour taking place in Washington, D.C. We just did Chicago last week, which was very good, providing a fertile ground for what we call ideas networks, where business and technology executives share inspiration with recognized partner companies and respected experts around the world, and we anticipate the same in Washington, D.C. So there's still time to register for that. Please feel free to reach out to us for any assistance, and of course it's on the front of the Software AG website, www.softwareag.com. So let's move now to the questions. We do have a number of them. And I think what I'd like to do, somewhat out of order, is to start with one that's actually called business question. So let's go with that first. Besides this fraud detection example, could machine learning be used in business processes to check that a company's internal controls are being adhered to?
This is Mark, and I would say absolutely. Clearly, you have to have a definition of what business processes you're wanting to look at. So for one example, Software AG, I'm just going to use one in the financial markets, offers a market surveillance application that is based on APAMA, and that's used to look at issues around what's happening with regards to companies that do financial trading, and seeing, making sure that all is right in the world within those operations, and what needs to be investigated, and where something, might have gone wrong or is about to go wrong, and looking at that. So that's just one example. Software AG is very involved. Also, if you're not familiar with GDPR, the General Data Protection Rule that's coming into play in Europe and affecting most large companies mid-next year, that's a whole nother webinar and a whole nother conversation, but come talk to us, and we do expect that predictive analytics and fraud detection and machine learning will be used in those processes over time. So I'll end there, and Eddie, if you want to add anything to that.
No, I think you summed it up pretty nicely.
If I may, just from the same customer, an afterthought, does one have to monitor the machine learning to make sure that it continues to produce the desired results in a sustainable manner?
The answer is yes over, do you want to go ahead and,
let me take that.
Sure, of course.
Absolutely, because machine learning, once you deploy it, doesn't stay accurate all the time because the condition changes, and so you have to implement a monitoring process to make sure that the performance of the monitor in production is still up to par. And if you detect that it starts to deviate or degrade to a level that a threshold that you say it's not good enough, that's when you need to either decide whether you may have to retrain it, and if retraining still doesn't help, you typically would have other models that are built alongside this one, which are called candidate models or challenger. And if they are better than the ones that are than the ones that is in production, which is at that point the champion, then you would have to swap it out. So the answer is yes.
Thank you. We're going to go to some technical questions now. Firstly, let me just say to the gentleman who asked, can we send you an invitation for the Washington, D.C. Innovation Tour? The answer is yes. And to anyone else, just give us a nod in the chat box and we'll do the same for you. Also, with some of these very technical questions, we may get into the weeds, so we may follow up after the call or the presentation, and also feel free to initiate contact with both Eddie or Mark using the email addresses at the bottom middle of this slide we're looking at right now. So here's a technology question, but it's only 3 words long. What is scoring?
Scoring
is one good answer. It's prediction.
So I would give a little more detail and say, anytime that you run a model, what you're going to get is a numerical score. That numerical score might be between 0 and 1, or the one we're most familiar with is credit scores, right? Anywhere from 350 to 850. Often, you will then need to take that score and translate it into an alpha, again, with regards to credit scores, poor, excellent, great. If it's a transaction, approved, not approved, right? All these sort of things. And within PMML, you can do that transliteration of the numerical score to the alpha score, and we can send those scores to any application, database, or visualization tool that needs to utilize them.
So how does a model know whether or not the data it is executing against is valid data?
Sure, and that's a great question. It's really important, particularly in this world where you're looking at real-time analytics and you're looking as well as perhaps things like Hadoop, where the data may not be as clean as it historically has been in some structured databases. And even in structured databases, there's a lot of questions about data quality. And so the good news is that PMML has all the capabilities you need for pre- and post-processing of data, or data handling and transformations. So just in the last answer, I talked about the post-processing, right? Pre-processing means you're looking at the data and maybe you need to infer a missing value or handle an outlier or smooth out a curve. So you can put all of that in the PMML that is your model and make it unique to each model and each use case that you're dealing with. It's all right there. Now, what you don't want to use PMML for is things like joins and aggregations, right? So that's what databases are designed to do, and they're excellent at it. So you definitely want to do that stuff with the database, but again, we can do quite a bit with data to ensure that you're getting high-quality data in, so you get a high-quality score, which then can be utilized.
Can transaction monitor display only suspect TXN and then show all the approved TXN and others?
Yeah, I think you're referring to the demo, for example. What I've done is I did not filter it, so I show every transaction that comes in and then highlight the ones that are suspect. I can certainly filter everything out, all the normal ones out, and just show the suspects. So yes, absolutely, we can do that.
And how does Zementis AI decide that the TXN is suspect? Are there any inbuilt algorithms, or are they customized? Is it with code? Any?
The way that is determined is really dependent on the customer. What the machine learning model has provided is as a probability of a certain outcome or certain, for example, in my demo, probability of fraudulent transaction. So the customer would have to then decide what level of probability is considered suspect, and those below it is fine. So it's really a customer call.
All righty. You may want to sit down for this one. What is the strategy of integrating Cumulocity, Apama, and Zementis with respect to IoT?
Okay, I'll take that one. So Cumulocity is a company that Software AG acquired just a few months after Zementis. And their specialty is connecting and managing and providing basic analytics for any type of IoT or connected device. And it's a great product, an incredible user interface. If you're interested in that sort of thing, you should really go check out the demo on the Software AG website. It's really excellent. Now, obviously, to do all of that, you need a real-time streaming process to make all of that work, right? So that's what Apama is providing. It's streaming the data that Cumulocity is leveraging to provide either the base level analytics that are available natively in Apama, and then Zementis provides a module called Apama Predictive Analytics. So wherever you have Apama, you can seamlessly deploy these predictive analytics. And so that's really important with IoT, because let's assume you're going to have thousands or tens of thousands or hundreds of thousands of devices, all throwing off data in real time. And again, going back to my comment about browsers and phones, smartphones, right? The only way you get the full economic advantage of implementing an IoT system is if you can make actionable economic decisions in real time based on the data that you're getting. So of course you're going to need predictive analytics and machine learning and AI. And again, you're not going to be able to take 3 or 6 or 9 or 12 months to deploy models, right? Your competitors will kill you if you're doing that. So you're going to need this rapid deployment of AI into whatever IoT environment you're using. Now, I'm sure we'll do a webinar in the future about IoT. We just launched at the Chicago Innovation Tour. We'll be talking about more at the Washington, D.C. Innovation Tour, Cumulocity IoT. And I am, if you can't hear it in my voice, I'm so excited about this. It's really worth checking out.
Well, thanks for that enthusiastic and expansive response, Mark. Is WebMethods ML capability to import and deploy the PPML, is that a service? Is that done as a service?
The WebMethods there is a flow package, one that is developed by the field, and another one that's coming out as a product in October. I believe that it's in there. The ones that's coming out as a product is what we call a WM package that is implemented in Java. The one that I was using was something that is a flow package that was developed by the field team. And if anybody's interested, we can share that with you, just as something that you can play around with. Just email me and I can share that with you. Otherwise,
is there any other way to import a model besides PMML?
We can take in Java as well, and I'll do one exception comment here. If you want to do something that's not available in PMML, although PMML should be able to support pretty much anything you want to do, you can code whatever you want to do in Java, and we can bring it in through a custom call. So you're not strictly limited to PMML.
Is DevOps applicable to the deployment of PMML models? If so, can you please elaborate? Should we take that one offline?
No, well, I'm going to turn it over to Eddie. At least I don't know the answer.
Well, DevOps would normally get involved in the deployment of the model, but the actual details, I would have to take it offline and direct that answer later on. Is that okay?
Sure. Well, that's part of the deal. Thank you. That's totally acceptable, and we will absolutely follow up on that. Final question for the hour. What if I want to use an analytic outside of the PMML standard?
Sure. So I think I talked a little bit about that in the previous answer, which is you could custom code that in Java and then call it from within the Zementis Predictive Analytics or Palma Predictive Analytics package using a custom function call, and it'll work just fine.
Our thanks again to Mark Rapkin, Eddie Sung, and we hope to see you back here next week. Building your company's next killer application is about an entire platform actually called Dynamic Apps, so we'd like to make you aware of that this time next week, and we're following up with other types of cutting-edge strategies. And also note on November 8th, we have something called Giving Voice to Your Business Application Integration. I don't want to drop a hint, but one of the guest presenters will be Alexa. In the meantime, look forward to you all coming back at some point, and have a great rest of the day.